Okay, let's take a look at sample exam 2, Chem 11, number 12. In this question, we're given 4 different statements, and the question asks which of the statements are true. So what we have to go through is just analyze each of the statements and see which of them is true and which of them is not. So let's start with statement number 1. It says that at constant temperature, the lighter the gas molecules, the higher their average velocities are. Okay, the gas velocity or the gas speed equation is URMS equals to the square root of 3RT over m. And of course, this equation tells you that there is an inverse relationship between speed and molar mass, which just means that the lighter the molar mass, the smaller a number here at the bottom, the bigger the speed will be, which is what that's saying there in statement 1. So that would be true. The second one says at constant temperature, the heavier the gas, the larger their average kinetic energy will be. So for this one, you need to remember the equation for the average kinetic energy for 1 mole of gas. That only depends on temperature. It doesn't depend on molar mass. So in other words, if you have the same temperature, whether you have a small gas like H2 or a large gas like xenon, they both are going to have the same kinetic energy at the same temperature. So that's going to be false. The reason for that is because the kinetic energy depends on 2 components, which is mass and velocity. When the mass is bigger, the velocity ends up dropping. And so the mass and the velocity kind of balances out each other such that the kinetic energy ends up being exactly equal. Let's take a look at number 3. It says here, as temperature increases, the attraction between gas particles also increase. So this goes to that discussion about the difference between ideal versus real gas. A gas is considered to be ideal if there's no interaction and the gases are so small that the volume is considered to be 0. Remember that what temperature affects is kinetic energy. So if temperature increases, then the kinetic energy of each gas particle also increases. Now, the reason this plays into the behavior of the gas is particles do attract each other. They all have protons and electrons which are attracted to each other. However, that attraction will only occur at lower temperature because gases are not moving as fast, so the potential energy, which is this interactions between the particles, are going to be felt more strongly because the kinetic energy component is fairly low. However, at higher temperature, when kinetic energy is also high, these gas particles are whizzing past each other. So there's really the potential energy component then would be relatively insignificant compared to the kinetic energy of each gas particle at that point. So then the attraction should also decrease as a result. So then statement 3 is false. Now let's take a look at statement 4. It says that when the volume of a gas container is reduced step by step, then the behavior of the gas particles will increasingly be more like a real gas. We assume in an ideal gas situation that gas particle has such a small volume compared to the volume of the container, we can assume that the gas particle has no volume, as I wrote here. However, if you make your container really small like this, and you have that same gas particle inside, now even though that gas particle is small, its size becomes significant relative to the size of the container. So at that point, we can no longer ignore the size of the gas particle, okay, or the gas volume. And so the volume of the container then has to be subtracted by the volume of the gas particle. And that happens when we have what we call a real gas. And so as you make your container volume smaller, let's say going from the left container to the right container, this is ideal. And as you go to smaller, this becomes more like a real gas. So the statement says, as you go reduce the volume step by step, your behavior of the gas will be more like a real gas. So that's a true statement. So in other words, in this case, 2 of those are true, which is 1 and 4. So that'd be our answer.